my name's Courtney, and I'll be talking to you today about heat. I'm sure all of you know what heat is. Maybe you've stepped on the cement with bare feet or touched a pan fresh out of the oven. Well, I'm here to tell you what's going on when you touch or feel something that's hot. Everything in the universe is made of atoms, and while these little guys aren't visible to the naked eye, they like to clump together in certain patterns called molecules. And they make up the things that we can see. For example, water is made of the molecule H2O. One hydrogen atom and two oxygen atoms. Salt is another collection of atoms. One sodium atom and one chloride atom. These are the things that we use every day, and they're made up of molecules. Molecules, on the other hand, are always moving. It may not seem like it, but when you touch something and think, oh, that's cold, it just means that the molecules in the item that you're touching are moving slower than the molecules in your hand. And if you touch something and go, oh, that's hot, it just means that the molecules are moving faster than the molecules in your hand. And I think that's pretty crazy. When molecules move, they create this thing called kinetic energy. Have you ever rubbed your hands together when it's cold to warm up? It's basically the same idea. Slow-moving molecules start to move really fast and bump against each other, and they generate heat. The energy that is created between these two moving molecules bumping and colliding and rubbing into each other is converted into heat. So when we touch something that has fast-moving molecules, we perceive that energy as heat. So today I'm going to make a thermometer that you can make at home with some pretty simple items, and this will give you an opportunity to watch the phenomenon of heat, basically. When water is heated, which is what we're going to be using inside our handy-dandy thermometer, it expands. And it expands because these fast-moving molecules are bumping into each other and hitting each other, and they're spreading out, and the faster they move, the harder they're going to hit. So while something that's going slow may not move very far, something that's going fast is going to move really far away. So the water expands, and in our thermometer, when we heat it up, we're going to be able to see the water rise into the straw, and it's just going to move to about however hot our thermometer perceives it to be. So what we're going to do is we're going to take a water bottle, we're going to take some rubbing alcohol, we're going to take some water. I have a funnel so that I don't make a mess. We're going to take a regular plastic straw. I have a box cutter for cutting this open. I have a little measuring cup, and I have some modeling clay. I am going to go get my food coloring. Now, your food coloring doesn't have to be red, but I make mine red just because it's a lot easier to work with, and I kind of think of heat as red, so it just kind of works. But you can make yours green or blue or whatever color you like. I'm using my box cutter to cut off the label. I would suggest that you have a parent do this or someone older, just so that you don't hurt yourself, because box cutters are sharp. So I'm going to cut this off. I'm going to spit it if it'll come off. Let's see. There we go. I'm trying to cut the bottle at the same time. And I'm going to close my box cutter. I'm going to put it over here. So what you're going to do is you're going to take, I'm using a 1/4 cup just because this is a pretty small bottle. And I'm going to use my funnel, and I'm just going to take one little 1/4 cup water, pour it into the bottle, and then I'm going to take 1/4 cup rubbing alcohol. So you're going to pour these in equal amounts. So if you add more water, you need to add more rubbing alcohol. You're just going to fill it up to the bottom. Fill at the bottom. Usually it takes about a little more than that, but I think this is enough because I don't want my straw to overflow if it gets too hot, because we're not going to be covering the top of the straw. We're just going to be covering the mouth of the bottle. So we're going to add our food coloring. Take this, take a couple drops, close that up, and I'm going to close my bottle, and I'm going to shake it up. Okay, so I'm going to take my straw, I'm going to take some of my modeling clay. I got this at Michael's. It's just craft shape or something similar to that. It's really not that expensive. It's just one little thing of modeling clay. I had enough to make this and this one at the same time, so it shouldn't take you a whole bunch of modeling clay to do this project. I got this rubbing alcohol at Target. You can get food coloring almost anywhere, and I just use plain old tap water. So let's see. So I'm going to flatten my modeling clay a little bit. Excuse me. And I'm going to poke my straw through and then I'm going to squeeze that clay out of there. Here. So I'm going to put the straw in, and it's not going to touch the bottom, it's just going to go into the water. But you don't want it to touch the bottom of the bottle. Okay. So this takes a little bit, because you want to make sure that the straw is nice and secure. Wrapped around. You don't want it to be touching the bottom of the bottle. And I just add a little bit more as needed. Make sure that it's nice and straight down there. Oh, you can already see the water rising. Okay. So, anyways, we've got and that's pretty much it. You've got your little homemade thermometer. You can take it outside, you can take it into your room, you can even hold it and you can watch the water rise. I will give you a close-up here in a second. Of how the water rises. Okay, so you're gonna take this and then you can watch. If I touch it, the water goes up. Even just the heat of my hand makes the water rise. See? Isn't that pretty cool? I'll do it with my other one too. I have this one that I made earlier, and I can just touch it, and as the heat of my hand warms the water, the little thermometer goes up. See? And then we can take it outside even. Let's go outside. And we can watch the thermometer rise. Pretty crazy. So, that is my little homemade thermometer experiment. I just wanted to give you guys a little lesson on how heat can affect our everyday lives. Because if you think about it, with everything that's going on in the world today, we have the global warming phenomenon, climate change, and we are losing the polar ice caps at an alarming rate. The ice that has been frozen for thousands and thousands of years is falling into the ocean and melting, causing the ocean to rise. The sun is beating down and the open ocean is absorbing more and more heat, causing the oceans to warm, which is very difficult on certain ecosystems like coral reefs, which are currently going through a phenomenon called bleaching, which is when the algae inside of them leaves and causes the coral to starve and lose that beautifully vibrant color. And it's just a vicious cycle. And doing something like this, you can just easily see how something as small as just a little homemade thermometer can show you the difference between the heat inside my home. You can tell the thermometer was even more than halfway up, outside, and now it's all the way back down to the bottom inside my house. So you have this fun little experiment to, see the heat inside your home and watch how heat affects just something as simple as water and rubbing alcohol. And you can see and understand, it'll help you understand how heat affects our everyday life, how it affects our world. So, yeah, there you go. I hope you have fun with this. I hope that you take household items instead of throwing away old soda bottles or old straws that you might get at Jack in the Box or McDonald's if you go out to eat. Use them, have fun with it. You can take a real thermometer and mark your heat temperature, and it'll tell you, what the temperature is of that day, what the temperature is in your room, what the temperature is in your kitchen. So please have fun with it, and I hope you enjoyed this video and a little bit of learning today.